Alright, so today we're looking at continuous random variables, a new topic in statistics, and we're starting off with something we call probability density functions. Now, probability density functions help us measure or work out if a function is applied with the three rules we have on the left-hand side, is what we consider a probability density function. So the three rules that we're looking for today are if the function itself is given within the range. So what that means here is if we've got a range and that data or the area that we're trying to find is within that range only, then we have a probability density function. If the total area within that range is equal to 1, then it is also a probability density function. And the last one is only a probability density function if the function itself is greater than 0, so it's above the x-axis. All three of these must satisfy for it to become a probability density function. So for example, if we have a look at the top one here where we've got the function of cosine, and we're looking at the range between 0 and pi. Straight away, if we look at this here, we're not going to worry about looking at if it is equal to 1. We can see that because it's gone from 0 to pi, part of this function within this range is below the x-axis. So we can safely say here that this is not a probability density function. However, if I changed the range, so the areas within this range here, and I did pi on 2, then this now satisfies the first rule and then the third rule. And then we'd have to work out the answer, because what we're looking here is we're seeing, does this part here, when I integrate it using this rule here, does it give me an area of 1? Now we're not going to do the maths on this one here, we'll do the maths on the second one, but this here would now satisfy the first rule, the areas within that given range. So none of this is below the x-axis now, and it's above the x-axis, so therefore it applies this third rule. However, in this second part here, if we looked at this and said, okay, well, does this satisfy this rule here? We didn't have to integrate it, and if it doesn't equal 1, therefore it's not a probability density function. It's not best out of 3, it must be all 3 must be satisfied. If we look at the second example that we've got here, where we have half sine x, we can see that we're only dealing with the function that's between 2 pi and 3 pi. Even though this half sine x will have some function where it will go below the x-axis, we're only dealing with this section here. So therefore, again, it satisfies the first option and it satisfies the third option. We now want to work out, well, does it satisfy the second option that it equals 1? So therefore, what we would do here is we would put in our function, and you can do this in your calculator as well, but we're just going to do it in terms of algebra here because it's a nice straightforward one. So we put this into our function here, and if we continue on with integrating it, we would get negative half cos x 3 pi to 2 pi. So if we integrate this here, let's bring out the negative and then have cos x 3 pi to 2 pi. We can then say therefore we'll get 1/2 is equal to cos 3 pi minus cos 2 pi. And if we're looking at this here correctly, we should get an answer that will help us solve it. So therefore negative 1/2. Now cos 3 pi is equal to negative 1 minus cos 2 pi, which is 1. So therefore negative half times negative 2 is equal to 1. So this function here is an example of a probability density function. It's a valid probability density function because it's above the x-axis. The area we're looking for is within that domain or that range, okay? Or in this case, and it's above the x-axis. So therefore, this function here is what we would consider a probability density function. We also have to know how to work backwards. So if we look at a second question, let's get rid of all this. Okay. Let's put a second function up here where we want to find the value of an unknown. So we have f of x is equal to a square root x, and we're looking between 0 is less than or equal to x, which is less than or equal to 4. And we know that this here is a valid PDF. So if it is a valid PDF, we know that the function here, between 4 and 0, is equal to 1. So if we're looking at this function here, we need to be able to find the unknown variable of a. So in this case, we need to integrate this function with respect to 0 and 4. What we can do is we can bring that a out because it's a constant. So therefore we can have is equal to 1. And now we can integrate this as normal. So a 4, 0, x to the power of half dx is equal to 1. If we integrate this here now, we get a x to the power of 3 halves over 3 halves to the power of 4 and 0 is equal to 1. So if we continue solving this, leaving our a on the outside for now, we know that we're going to have 2/3 x to the power of 3 halves, 4 to 0, so therefore a is now 2/3, 4, 3 halves, minus 0 is equal to 1. Now we know we're not going to get a 0 for the second part, but what we can get for the first part is if we get our calculation here, 2/3, what's that going to give me? That gives me, I think, 1/8, doesn't it? Yeah, so it gives me 3/16. So I would get a is equal to 3/16. Okay, so we now work a out because we've calculated our unknown variable, okay, subtracted it away from 1 and worked out whether our a is equal to 3/16. So this here is a valid density function calculation between the points of 0 to 4, and we want to know an unknown, we want to find the unknown variable here. So for instance, therefore we could say the function would now be 3/16 root x as your final solution here. So if I wanted to find out a different part, say for instance between 1 and 2, I now have a function for a that helps me solve it. So the probability density function comes down to the 3 rules. The area is given within the range, the total area is equal to 1 when we integrate it, and the function itself has to be greater than 0. See you next one.